Alright, guys. In previous video, right? What we did was we are activating our virtual environment, right? As you all know. And last we have our Docker compose file, right? And what we will do, we will do this. Okay, Docker db. Alright, no service what? Like this. Alright. So container regular.db one started, right? So let me check the status also. Docker compose ps. So you can see image is Postgres this. Alright. As you can see here, created 2 days ago. Alright, status 30 seconds, TCP healthy. Alright, everything is running, right guys? And let me see one thing. Okay, as you can see here, right? Now what I want to see here is this thing, right? Alright, so here we are. Alright, our this round one is working perfectly. Our output is our output proves that PostgreSQL is running inside Compose, and health check is working here, right? So fish command is you can see here that so the name of the container, right, uh, is review radar db1. It is generated by the compose. Okay, so review radar is the project name here, and db is the service, and one is the instance, right? And our database is running from this Postgres 16 year helpline, right? We are using the official Postgres SQL image, okay? And service is equal to DB here. This is important because of this our compose knows that service name is DB. Therefore, other containers will later be able to reach PostgreSQL using only DB, right? So and status here is up for 30 seconds, which is healthy, right? And so in our this YAML file here, the Docker Compose file, what we did was we wrote this test, right? Here like test cmd cell pg is ready. We have to check like if that is ready condition is true or not, right? Then only we can go further. So after container started, we have to initialize the PostgreSQL, right? Then pg is ready will be true, right? If it is true, then only the connection will be accepted, and then only it will show that it is healthy, right? So this proves that our health check isn't just a configuration setting in YAML, right? It's actually being executed in real. Like we have to initialize in real the PostgreSQL, right? Yeah. You will notice very interesting, like ports here is 5432/TCP, right? And there is no like 0 port like this. So that's good. It means that you didn't publish PostgreSQL port to our host, right? And the database is available internally to the Compose network, right? But you haven't opened the host basic door for it. Okay, so that is good. And now what we will do is moving to round 2, which is API. Okay, so the important transition is in round 1. What we did was we had this Docker Compose, right? And Docker Compose started the DB thing, and we were reaching to the PostgreSQL plus PG data. Right now API will communicate, right, with a database using the host name. Okay, so what is the host name? Which is host name is DB. So API will talk to database using this host name, right? Which is DB, right? Not the local host, not like host.docker.internal, right? Okay. Okay, now what we will do, let's do one thing. What we will do, we will enter in Postgres SQL inside the container. Okay, so how can we do this? Docker compose. So this Docker compose is like, it is saying okay, use the Docker compose, right? Then exec, we are using this for like to say okay, execute a command, okay, inside an already running container. So this is what exec is saying. So Docker compose, like use the Docker compose, and when it starts the container, then execute the command inside an already running container. Okay, so we are saying okay, run something inside DB. Alright, so here now I can see okay, DB. So this is one of our services, right, inside the container, or it is the compose service name, right? So compose will find the PostgreSQL container, right, which is associated with DB, as you can see here in the Docker compose file here. DB is a service, right, and it is image is Postgres helpline, and environment as this, right? Everything is as a service is working here, right? So yeah, and we are saying okay, run this command inside the DB, right? Now this PSQL, what is this? This is the PostgreSQL command line client, right? It allows us to communicate with PostgreSQL. So this is PSQL, and we have U radar. U is, we are saying okay, user. So U radar means like username is radar. Connect as PostgreSQL user radar. Okay. Then D review radar. Okay, this means like D is database is the flag here, right? So D review radar like means connect to the review radar database. Alright, and C, this we, and then we have C. That means that execute this SQL or PSQL command and then exit. Okay, so then we have /DT. Okay, this is a Postgres PSQL meta command /DT, right? It asks that show me the tables in this database. Alright, it will ask like okay, show me the tables in the database, and C means the execute this command, press command, and this exit. Alright, so in simple thing, this complete command is like go to the DB container, right? Open the PostgreSQL here, PSQL, and connect edge radar, and show me the tables. Okay, let me run this. Extra command line DT ignored what? will happen. Let me run this docker compose exec dbpsql, right? U radar d review radar c so the output is did not find any relations, right? So what this is mean? This is not an error for us. Okay, it means that database exists, which is our review radar, right? And user also exists, which is radar, and this PostgreSQL works, right? But tables, there are no tables there, right? So number of tables are 0 there. Like database is completely fresh. Okay, why this database is empty? Because our table appears when API will boot initDB, right? So your application is responsible for the creating its table when it starts. Okay, so what we are doing, we are currently Postgres is running, but it has 0 tables. When we start the API, okay, when we start the API, then it will initialize the database, right? Then it will create tables, right? And those tables and predictions will go inside this PostgreSQL. All the predictions you can find and all that. So there is nothing to panic here, and at this stage this is expected. A very important thing is this is not your host PostgreSQL, right? Like this is not our host PostgreSQL. Yesterday we had this thing. Ubuntu host, right? Which was PostgreSQL at this 5432 port, right? And our Docker container had to reach it through like a host.docker.internal. Today what we have is different thing, right? We have this Docker compose, right? Inside it we have some API services and DB. Inside that we have PostgreSQL. So the database is now inside the compose stack. So our host Postgres is no longer the database that API will use now, right? That's why the line yesterday the host wiring problem didn't get solved, right? It got deleted. So it's a good way to think about it, and you didn't make the old architecture easier, right? You change the architecture. So what we can do, we already have the service, DB service, right, in Compose. What I can do now as a service, here I can run this API service also, right guys, called build. Alright, this. The important thing is that API is at the same indentation level as DB. Okay, so this API, this will create a compose service named API. Okay, therefore inside a compose network, so API is also the API host name now, right? So now we have this DB will point to PostgreSQL and API will point to okay, right, and API will point to the first API, right? And this build dot, this means that build this service. Okay, so this is saying okay, build the services image, Docker image using the current directory as the build context. Dot is like use the current directory and build is the build the service, right? And dot is the use the current directory. So our project have this Docker file and all, right? So it is saying okay, look here and look in this directory and find the Docker file. Where it is, here Docker file it is, right? Build any API image, then it will build the API image. So here in this we have the image, we don't have the build, right? Now we are here, we are using build. Why it is, right? So instead of image, for PostgreSQL, image is like, because someone else already built PostgreSQL, right? For our API, because we wrote the application, right? We wrote the application, so the PostgreSQL image was official image, right? But review radar, we have to build through Docker file. Okay, this is our API. Postgres is already built, like you see here. PostgreSQL is official image already, right? And we took the image only, right? But in our review radar API, we have our Docker file, right? It will build. We have to build it, right? So compose will build it automatically. We don't have to manually run okay docker.build like review radar API something like that, right? Compose, whenever compose sees this build dot, right? And it can automatically build the image when necessary, okay? So and the flow will be like Docker compose up will be a command, right? It will look for this, okay, does API image exist or not? If it exists, then it will not build that. If it does not exist, it will build that, okay? And then it will create the API container, right? Now next thing we will have this environment, right? Environment, okay. Environment, we have the first is database URL, okay, which is PostgreSQL. Radar is the user, right? And password is radar dev password, right? At db 5432 / review radar, right? So you see here the host name here is just db, because this db service is already running inside this network created by the Docker compose, right? And password is already there, and so we are using the db only, right? This is the service name. So why it works? Because compose is embedded DNS, right? Now is real. So as you can see, this PostgreSQL, what it is saying okay, this is the database type, right, or the protocol. So PostgreSQL is the protocol or database type for us, right? You are telling your application this is the PostgreSQL database. Radar, this is the database username, right? You can see here this is radar, right? Postgres user radar, and this is the password also, whatever the password here for the service, and the DB review radar, right? Same as our Postgres password like this, right? Now most important part is the DB. So this is the compose service name, right? As you can see here. Therefore DB becomes the host name for us, and your API effectively says that find the massive container named DB, right? So compose internal DLLs will resolve that, and this 5432 is the PostgreSQL port, right? So host name is DB, but port is 5432, and this is the database name as review radar, right? So to like yesterday, the flow was like this. API was going to host.docker.internal, right? 5432. Then it was going to the host DB, right? But now the changed thing is API here, right? API. Then we have DB 5432. Then we have DB container, right? Then we have PostgreSQL, right? So this is much cleaner. So this DB we don't need to do this. We just DB, we go like a host name and then port. It goes to the DB and container, DB container, and it will connect to the PostgreSQL, right? So localhost will not work here because inside an API container, like localhost means the API container itself, right? Not the DB container. So this would be wrong if I write localhost here like this. Instead of this DB, if I write localhost, then it will not work, right? And next thing we will have, guys, will be this ports, right? Next 8000. What this is mean? So this will publish the API to our host. Remember that host is container, right? So therefore 8000 this should be for host, and this should be for container, right? So host colon container here 8000 colon 8000 means that our Ubuntu machine, right? Localhost is on the port 8000, and our API container port is also on 8000. So we can run like this. When we have this localhost in our Ubuntu machine, right? What we do, localhost port 8000. We do this /docs and all, right? For the running the application, right? But what we can do is we have this API container. The port here is for 8000 also. So what we can do is we can run this command. We can run this command called curl http localhost, right? Port is 8000 /health. We can run this command from our terminal. Okay. So this localhost also points to our container. Okay, API container. So you see here, this DB don't have ports. Right? This is very deliberate because our database service has this image, this thing, right? So but there is no port. So host is 8000 is for API 5. So we can only access API now, right? So if we want to access a localhost colon 5432, which is the port of DB, we cannot access. But inside the compose network, right? But inside the compose network, API can access this DB/5432, right? This is the security topology, and the database doesn't need to publicly accessible, right? And the next thing we will have is depends on, guys, okay, which is let me show you, right? Now we have depends on, right? Service name is DB, okay, and condition will be, condition is service healthy. What is this, right? This will tell compose that API will depend on the database being healthy, not merely like, okay, DB container started, but DB health check must have to pass, okay. So remember this thing, our health check here, right? So the flow becomes, now we will start the DB, right? After starting the database, PostgreSQL will initialize, then PG will be is ready will be true, right? If PG is ready is true, then we can start API after that, okay. So that is why this is better than like depends on DB only, right? So the simple version only gives the startup only. So start, then health check, then readiness condition, right? Now we have two services, guys. One is DB, one is API. If I try to run this docker compose up D, validate and variable must be mapping. Right, what is this? Whatever. There is some problem, I think, accessing here, right? Or like I think I have some issues in the indentation and all. Okay, I think we need this thing here. SQL here also, right? And this also I think protocol, then colon, and the service being healthy, right guys? Okay, and okay, now it's good to go, right? So notice something here. We only run this not DB, right? Uh, because now we want the whole declaration check, right? So what does this compose do, right? This is where our earlier concept of reconciliation becomes visible. Okay, we already have DB as a service, right? Running and healthy, right? Now then we added API service, right? Now our desired state is like it should be running like DB and API. Like current reality is DB is running but API is not running, right? Therefore, the desired state is not equal to reality, right? When compose will reconcile the difference, right? Docker compose up, then compare the desired versus reality states. If DB is already correct, it will leave it alone. API is missing, then it will build the API image, right? Create the API container. After that, wait for the DB to be healthy and start the service of API, right? This is exactly DB already matches the declaration, right? Untouched. You can see here. Now image review radar API is built. It's healthy and now it is started, right? All right, then. All right.
इसके मैंने तो आधा बच्चे मर जाते
Alright, so now our two services are running, guys, right? One is API and one is DB, right? Now we will add UI, and then we will prove that the entire system works with only one command. Okay, first and foremost thing is here, API has started after the DB became healthy, right? The important idea from the previous step is that depends on, like, this condition here, DB service healthy, right? So compose does not simply do like this start the DB. After starting the DB immediately, we will not start the API immediately, right? API container. Instead, what we will do, we will start the DB, and we initialize the Postgres SQL database service or image, right? Then we health check that if it is running, then PG is ready will be true, and it's healthy. Then we will start the API, right? Now we can also test our API if it is working or not, right? By uh, like curl http, right? Localhost HCL. Port we have to also mention, like 8000 slash. You see status is okay. That means I am the API is a container is running, right? So because our from localhost, right? Here it is. This is for localhost. This is for API container. Right? This is the host and this is the receiver. The API container, right? So this is proving us that our container API container is running. Fast API also running. Port 8000 is published, right? And this health endpoint is also working, right? Now we will test the prediction endpoint also. Okay, let's see and make the request something, right? Curl x host, right? TTP localhost 8000 slash predict, right? Then we have header, and header is like this, what? Host 8000 slash predict. We have header. The header is like, okay, content type is application slash JSON, right? Then we have data, actual data, text as a field here, and compose networking is great, let's say, right? So if I am sending this, so you see what happened? Detail not found. What? Content type application JSON D is great. It should have worked, right? Curl x post localhost 8000 predict. Header was there. Content type we have dialed like application slash JSON, right? And we have data, text, right? Text is like this. It should have worked, guys. What happened? detail not found. Where is detail I am saying? Well, let me clear it first, right? Then I am going to content the text composer. Detail not found. Okay, guys, I think I made some mistake here, right? In the command. You can see here that the here predict endpoint here, right? It is wrong. What? What? Okay, it's still wrong, guys. What to say? What happened now again? Okay, it's all. Let me do one thing. Okay, curl x host p, right, localhost 8000 predict, right. This is our header. Content type, right. Application slash solution, right. Then we data we have, which is this text. We can say that compose, right. Compose networking is good, right. If I send this, so sentiment is positive, confidence is also there. So right now, what is happening, right, sir? This is very important. What is happening here? We send a curl request, right. Curl is just a client for HTTP, right, request. Like we don't need to open the browser to send HTTP request. Directly we can send. And API container, then ML model prediction is there, then database container will go, right. After that API response will there, and curl response will get, right? So the database is now containerized, right? Before, what we were doing is was the API container was sending requests to host the PostgreSQL, right? Now what we is doing, API container is sending requests through Docker network to the DB container, right? That is a major change here, because we are running in the same network now, right? If I check the logs, Docker logs, right? Compose logs API, right? API is a container, tail 20, and you can see here this 120, this post predict, we have this not found, these were the failed requests, right? So you see here Docker compose is talk to like compose application, that is we are seeing here, and logs, like so the container logs, and the tail API is so the last 20 lines only, right? So Docker compose, this means like show me the last 20 lines generated by the API service, right? All right, so what happened here, this the API as it starts, right? Database URL was there, through the Docker container or Docker DNS, right? PostgreSQL container was reached by the API, and the database was initialized, and the tables were ready, right? So all right, so now in the round 3 we will add a UI service. This creates the third service now, right? Our architecture will become from UI we will talk to API, then API will talk to the database, right? So how we can build this UI, right? Guys, on the same indentation as API, we will have this next service called UI, okay, and it will have build, and after build, in the build we have context also, right? Then context will be our Docker file, right? Docker file.ui, right? So this is what we have built. Okay, so here it is. So UI is the service name, right? Therefore the other containers can reach it using the UI host name, right? Then build is unlike PostgreSQL. We are building our own image here also. Right? Remember this that PostgreSQL was image. Then API and UI will be the build, because and the context is the current directory, right? Like this review radar here, right? And this you can say here this what the heck? Right, this directory, present directory, right? And context, and so Docker can access files inside this build context. Okay, now Docker file. So normally Docker looks for Docker files, but our UI has this Docker file dot UI, right? As you can see here, it is, right? So therefore we explicitly say that Docker file is like this, right? So review radar Docker file, simple Docker file is for API, and Docker file dot UI is for UI, right? So one repository can therefore build multiple images also, right? That's how we can give different Docker files some different names, right? And then we will have after build we will have this environment, and at the build indentation level, right? So environment, right? It is a API URL, right? HTTP API / 8000. This line is very important, guys. Okay, because we are giving the UI a configuration value, right? API URL is equal to this, right? Why API? Because API is the compose service name, right? So we have to access that API, right? So compose DNS will resolve it, like UI will send this HTTP request to API / 8000, right? This will reach automatically to the API container. No IP address needed, no local host needed here. We don't need to slash localhost and all, right? No host.docker and anything, right? So because inside the UI container, right, localhost means the UI container itself, right? So we cannot use localhost here, but the API is a different container. So this would be wrong in that case, and API is equal to the API service which is already running, right? So you see here UI.py here, right? You see this is hard coded here. API URL is hard coded here, right, in this file. So that works when both programs run directly on our laptop, right? But inside Docker, UI container is on like localhost, right? And which is UI itself container, not API, right? So we need configuration instead of hard coding here, right? So the fix is we have to edit this file now. We will import OS in this case, and API URL will be this. Instead of this, we will have os dot get environment, right? And API URL, right? HTTP 127.0.1 8000. Right? So what is this doing? So this is very useful pattern for us. Like import OS is used for import the Python operating system utilities, right? Now this os dot get env is it will read the environment variable, right, which is API URL, right? So that means that give me the value of the environment variable called API URL, right? And the second argument is this 127.0, like, so it will be a default value. If we don't get the API URL, then this will be the default, right? So this is very powerful because now same code works in two environments, right? Running directly on your laptop, this will work. Uh, the local host, right? No API, when the no UR API URL supply, then default will be this, and when it is running the inside compose, then API URL will be API or colon 8000, right? So API URL will be API colon 8000 we have, therefore the same Python code, different configurations here, right? So this is the called the configuration overhead coding. Okay. So when it is running, it will get the environment from here, right? Docker compose UI build. From this UI file, this will be API URL will be get. This is the environment, right? It will go to that environment variable, right? Then after that we have ports also. This also need ports, right? So in parallel to just wait a minute, guys. I am figuring out something. Okay. Alright, and let's set ports also, right? In the environment thing, right? Ports is like this, right? 8501 and 8501 here also, like this, right guys? Not like this, I think like this, right? And at the end we will have this like that. And at the end after that we have this called depends on also, right? Depends on API, right? API service. If API is running, then it's plain frame, like there is no health condition in this, because UI degrades gracefully if the API lags, right? So the try except condition UI earns its keep, so start order is enough in that case. Okay, so now what we can do, we can build a Docker compose up build, right? So container UI is also started, guys, you can see here, right? So this dash dash build will force image rebuilds where the source changed, right? Because UI.py already changed, right? So we edited that file. So new docker file.ui also we edit. So the moment stages properly, right? So you see here, this is all running, right? If I go on localhost here and 8000, right? Localhost 8000, folks, it's running, but not in the 8000. Why I have to go to the 8501, right? So alright, so what can I do, guys, is like if I run this command docker compose down, right? What it is like, all it is removed all the containers, right? All the stack containers and the network also. So what we have to check that if volume survives or not, right? So doesn't touch volumes unless you add like says like specifically say to remove the volumes, right? So everything is off, dead. Now remember this morning's ritual, right? Post your service first API another terminal to stimulate for those. So if I run this docker compose up d here, you see this is waiting, this you see rebuild.db is waiting. Now it is healthy, then it started API and UI, right guys? So if I run this docker compose ps, right? So you see here 20 second, then 90 second up, right? There's a 63 second gap here, you can see here, right? So we have one is API, one is DB. Where is UI service? API is there, DB is running. UI is running or not? Right. If I running localhost 8501, this should be accessible, right? It's not accessible. Alright. Alright. Okay, it's not showing the, I think, the UI, right? UI is not showing here, so let me again check docker compose ps. It's not showing UI, right? So what I can ask is docker compose logs, right? UI container. Script. Okay. Thank you so much, guys, for watching. We will meet you tomorrow.